What is that, Ben? What is it? Is that a radio? Let me see. Is that your radio? It's your radio. Radio. Yeah. What is that, Ben? What is it? Is that a radio? Let me see. Is that your radio? It's your radio. Radio. Yeah. What is that, Ben? What is it? Is that a radio? Let me see. Is that your radio? It's your radio. Radio. Yeah. What is that, Ben? What is it? Is that a radio? Let me see. Is that your radio? It's your radio. Radio. Yeah. What is that, Ben? What is it? Is that a radio? Let me see. Well, what is up, everybody? Welcome to the Ham Radio Crash Course. Got a big day, big announcement. Big announcement. Do you see what the big announcement is? You're looking at it. You're looking at the big announcement. What is the big announcement that we have? It's a new day. Got a new special, a bundle of joy has graced my home here. Yes! Yes! I'm so excited. New radio day, guys. New radio day. ICOM 7300. There's actually a rag chew going on right now. And it's like, these guys are close. Listen to this.
Yep, 75 degrees all year round with 100% humidity. The wind is starting to pick up here again.
That guy's 20 over. Remember I was saying 20 plus 20? There's also a lot of lids on this one. But they're super close, so I thought, hey, that waterfall though. Look at this. There's something going on over here, so we're just gonna go boom. We jumped over to it. You just jump around. Beauty. Oh, so good. So good. So excited. 80's pretty hot right now. Well, we'll explore that another day because I got to get warmed up with it. But all right, let's get the good stuff, the news out of the way first and foremost. Remember, we're doing this to move forward with radio, meaning we take what we know, starting from a foundation, and we keep building up. We keep using what we know, the tools that are in our toolbox, and we keep building and building and building. And today's a good example of that. We're continuing down our general license path to get our general license. Some of you already have it, which you've been posting on the Facebook group, the Ham Radio Crash Course, which has been awesome. Some of you guys have been going out there and you've been taking the technician and the general at the same time and knocking them out, which is awesome. Please, if you do, go take your test, or you want to talk about taking the test, anything, go join the Ham Radio Crash Course on Facebook. Also, we've got Zach in the chat. He's posting a link to the Discord. The Discord is like a chat room, text chat with audio that I always go to at the end of these live streams. This will be no different. At the end of this live stream, I'll hop over there and I can answer your questions directly. So let's talk about moving forward with ham radio. So today, I bought my 7300. Some of you already know that I have two antennas on my roof. I have a G5 RV, which is it's basically like a doublet that's kind of mixed with a dipole tuned to 20 meters. Now, that's my HF antenna. It's just basically kind of a weird dipole. It's a weird dipole that's kind of sort of resonant on 40 meters and 80, and it's kind of okay. It's okay across the board. The problem that I learned today was that my SWR is just too high for the 7300. The 7300 has a tuner built in, but it only has a tuner that will take it from 3 to 1 down to something usable for the radio. So when I key up, I'm only getting about 20% of the maximum power output, which is about 100 watts. So lesson learned. I had a let's see, I had the G5RV using its ladder feed line connector to the coax. That's not a balun, that's just a straight connector out into coax. And it worked horribly. I was using my rig analyzer, and it was bad. It was 10-to-1 on the SWR, so I ended up going back to Ham Radio Crash Course, which I'm going to post a video on that because the guy who sold me the guy who sold me the 7300 today is the same guy who sold me my first radio, the Yaesu FT60R, which I still have, which I still use. So ended up, they had told me, hey, you probably should use a 4-to-1 balun, which I have a 4-to-1 balun already. That'll go up to 200 watts, so we're perfectly good. Ended up plugging it in. I got it down to 4-to-1 SWR, and the radio just will not take it down that final step. Because what happens, I can show you what happens here. So this button here turns the tuner on, which is that, and if you hold it down, it'll attempt to auto-tune. The fact that it went boop and then went away means that it can't make the match. It can't bring the SWR down. So that's okay. No big deal. Nobody's late. We just got started. This is the news. This is getting the stuff out of the way. Tom Garcia. That's a good. I didn't know that. I'm glad. He's saying the ICOM 7300 can handle 10-to-1 SWR in emergency mode at 50 watts. Good to know. I'm assuming that's not the tuner that's doing that. I think it's just the radio is just pushing it out. It just doesn't care. It doesn't hold back. Because right now what it's doing is it's trying to reduce the power output to match the SWR. Now, if you hear the background noise, I apologize. This is kind of like my birthday weekend. We're having people over this weekend. My dad's in town. A lot of people are in town. So got a ton of stuff going on. This not including, the 7300, which is awesome. 7300s are 1400, I believe, is the base retail. And then so basically it was $1,200 with a one-time $50 instant rebate, and then there's a mail-in rebate, which I need to mail into ICOM. So that brought it down to $1,200. With that said, Ethan, who's sometimes in the chat, he's commented a lot about how they're coming down in price in the used market. So if you keep an eye on the used market, you might find a really good deal. Okay, so that's out of the way. You're going to see way more video on the 7300. In fact, I'm going to do one. I'm continuing the emergency comms video, hopefully this weekend. I'm going to have some time off, and I'm going to get a very cool video, I think, done. Anyway, today we got the AleSmith Horny Devil to go along with our studies. This is I believe this is a Belgian triple. This is... Well, it's a Belgian-style golden ale, so that could be a cross between a triple. Belgian beers are my favorite beers, so... My dad's trying to keep the kids quiet right now. 7.3s, everybody. 7.3s in my beer cup that my dad gave me that he brought back from Thailand when he was in the Vietnam War. Biru. 7.3s. I made the modification there, so... Beautiful. I love Belgian yeast. You love Belgian yeast. So, last couple of things. W6 TRW swap meet is going to be this week. Next Saturday. I am going to that. I'm back to the regular schedule, so hopefully I'll be able to attend that, at least for a little while. So if you're planning on getting your, taking your technician or your general or your extra, and you want to do it at the TRW swap meet, W6 TRW is what you Google. It's in Redondo Beach, California. I'll be there, as always, looking for deals. I'll probably have Edison with me. All right. Ooh. Okay, so I'm going to switch over. Now, I wanted to show you, I only have 2 webcams, which is probably all I'm going to have. But that means I can't do the overhead book thing and also show you the radio. So we're going to have to say adieu to the 7300 at least for a little while. So let's do that right now. I didn't really plan this. I was just going to wing it. So I'm going to switch off of this so you don't have to see all my ridiculous... Oh, while I'm doing this, I'll talk about this guy. So you heard those guys that were talking earlier, and I got into a bit of an argument with somebody on the YouTube side on a comment, and it was about the FCC not really having any teeth and not really being able to kind of like stop anybody from spreading interference around. And that's kind of a true statement, because what you're looking at right there is a guy. His name is William Crowell, and he's from California. Of course he is. And he's gotten $25,000 fine issued to him by the FCC for his intentional interference that he's been doing for quite some time. And he's been fighting it. He's been trying to prevent them from getting their hands on his money, which that is his right, because that is all of our rights in the American judicial system. But at the same time, it doesn't really tell you much that they can police their own or police us, right? Because they didn't have a lot of teeth. Not wrong in what he's saying. Yeah, it's from 2000. It's from 2016, but it's ongoing. He still hasn't paid. He's still fighting it in the court. So, don't worry about 2 years, because in the government's eyes, 2 years is not that long. Okay, we're gonna have to move some things around here. How do we want to do this best? Okay, that'll have to do. Okay. Oh, this great cable here. That's wonderful. I was so excited to show you guys my 7300 that I didn't do my due diligence. All right, so let's get the mic cable out of the way. So today we're going to be talking about components and circuits, chapter 4. This is one of the funner chapters. If you're kind of like a double E guy, maybe you're an engineer, that kind of stuff. A lot of this stuff's going to come in easy to you because it's stuff that you already know about. So this is a long chapter too. Probably not going to be able to knock this out in one day. Can you read that? I think you can. Okay, so getting ready to lift the hood and learn more about electronics, the heart and soul of what makes radios go. As a general, you'll understand basic mechanics of how simple circuits work and how the components work together. That understanding enables you to adjust the equipment and maintain the station knowledgeably. So that's what this chapter is about. It's kind of about explaining what some of this stuff is, right? So you got some capacitors, you got some wound toroids here. So it all starts with an electrical review: currents, voltage, and power. Electric current is the flow of electrons with 1 unit negative electron charge and is measured in amps. Makes sense. Voltage is the force that makes electrons move. How many volts something has, right? When you talk about a stun gun that shocks somebody, 5,000 volts. Oh, you know what? We're not going to use the autofocus because it's not very good. That's going to be a lot better for you guys. Hopefully that text is a lot better to read now. Right, so the polarity of the voltage refers to the direction, positive and negative. Power is measured in watts, right? So this radio, the 7300, 100 watts. Sorry for adjusting the camera there. Okay. And, all right, so a lot of people were saying in the Ham Radio Crash Course that tried to do their general and their technician in the same day that a lot of the general is kind of rehashed technician questions. So if you learn the concepts in the technician test, you'll do fine in the general. Generally, that's a true statement. So, for example, we're going to rehash resistance and Ohm's Law. Got a lot of stuff. Ooh, buddy. A lot of notes here. So, remember we talked about the circle, right? You just cover up the E, and then you're looking for I or R. P, power, is induction. Again, you just cover, and that's what you do. So I times R, I times E, P divided by I, E divided by R, I divided by E, right? And that's so what you're deriving for, what you're looking for. The Ohm's law states R equals I divided by R equals E divided by I. If you know any two, I, E, or R, you can determine the missing quantity. This is a total rehash from technician, so you're just going to do the same thing that you did there before. Also, scratch paper is probably going to be a good thing to have for your general test. So keep that in mind when you go to, when you think about taking it. Calculators, you can use a calculator, but you can't you can't use your phone's calculator. So all those things, keep them in mind. The voltage cause. So another step. I've highlighted things that I find important, but what you really need to highlight, what you really need to focus on, is anything that has this nomenclature of G5B03 and anything in brackets, okay? That is their way of tracking the question pools from the test. So those are direct questions from the test. So you can skip a lot of this ancillary stuff if you don't really care about it, as long as you're focusing on those questions and you understand why what they're saying works. So their kids are having too much fun. I think I'm going to go beat them later. Just kidding. I'm not going to do that. The drawings in Figure 4.1, right, this goes back to the circles, are aids to remember Ohm's Law. To find out how many watts of electrical power are used if 400 volts DC is supplied to an 800 ohm, that's an ohm symbol, resistor, you're going to take 400 times 400, right, because it's volts DC, so it's squared, right, because this is an E2 over R squared. So you get 1600 over 800 is 200 watts. That's a direct question from the question pool, okay? Pretty straightforward. Who's a lefty? Why? I'm not a lefty. Sorry, I'm back up in the chat and getting some beer. Ellen, you're saying that the guy who has the fine is a lefty. Got it. Okay, so this is an interesting one. I like this question. Well, it's a part of the pool, but to find out how many watts of electrical power are used by a 12-volt DC bulb that draws 0.2 amps of current. That's a practical thing to know. Very easy. Just take 12 times 0.2, 2.4 watts. Simple. Very simple. Very practical, very simple. So to find out how many watts are displaced when a current 7.3 milliamps of current flows through a 1.25 k ohm resistor, you're going to take the 0.007, because it's milliamps versus the kilo ohm, and again E squared, and just multiply that times the 1025, and you get 0.06125. Now, I'm not going to spend the rest of the I'm not going to spend the whole video doing equations like this, because they're fairly straightforward, and there's something that you're going to have to remember anyway. Watching this video is not going to help you remember, because I'm not going to repeat it over and over again. And the way you remember things is to do and repeat. So you're going to take just these three equations, right? You can take all of these and just replace the 400 with 800, and replace this resistor with 600 ohm, right? And figure out what the value is. Get the correct value, derive the correct answer. Same thing for the draw of the light bulb, right? Okay. So AC and DC waveforms. Currents that flow in one direction all the time is a direct current. Hopefully, I would like to point out that the mere fact that this book is saying this shows you that it's still kind of at the technical low level. General is the second step on the ham radio. It's the second of three steps of the ham radio license progression. But even this is just very basic, right? Direct current is a direction, right? It just goes in one direction cycle. AC is alternate, goes back and forth. Okay? Current that reverses direction is called alternating current. And it's abbreviated AC, right? Okay. A voltage that has the same polarity all the time as DC voltage. A voltage that reverses polarity is AC voltage. Makes perfect sense, right? So, frequency, a complete sequence of AC current flowing, stopping, reversing, and stopping again, is called a cycle. The number of cycles per second is the current frequency measured in hertz. Okay? A harmonic is a frequency at some integer of 2, 3, 4s, and etc. So, that's cycle to cycle, right? A wavelength goes up and down, right? Up and down, up and down. Same concept. That's a full cycle. Tom Garcia says he's been studying for extra for 3 weeks, and he's only getting 50% correct on the practice exam. That's a good time to mention, guys. If you're not already doing this, please go download the practice exams that are put out by the ARRL. This book we're using is the ARRL book. It is linked in my description. You can go check a video description to Amazon. You can find the book. I like the Amazon book. I like and I don't like it. I like Gordo's books on average, particularly for a technician. His book's great. It makes you really interested in wanting to become an amateur operator. The general book, though, there's things that I prefer the ARR book. Anyway, yes, I'm left-handed. Oh, he's talking about me. Okay. Sorry, Ellen, got it. There is no, going back to harmonics, there is no first harmonic. There's a second harmonic, a third harmonic, etc. Okay, this is good. This is fun. Sciencey stuff. Wavelength. The speed of light in space is 300 million meters per second. So we use that as a constant, right, when we're measuring frequencies and whatnot. And the kids are going to get it when I'm done here. Right? So, and it's somewhat slower in wires and cables. The wavelength, which is kind of measured with this symbol, which looks like the Half-Life logo for those of you that play the Half-Life, of a radio wave is the distance it travels during one complete cycle. And there is an equation for that. Okay, so the wavelength, right, equals C over F, and F equals the C over wavelength. And that gives you whatever you're looking for, frequency, etc. Okay. Let's jump to another one of the tests. Oh, serial and parallel circuits. Okay, so this is something else that's kind of important to understand. Yeah, hamstudy.org is really good too, and free. So is my stuff. It's free. Yeah, Gordo's is fine too. You can do just fine with it. So parallel versus serial circuits. The way to look at circuits is you have a load, something you're trying to put power into. It could be very complex or it could be very simple. And a lot of times, even complex circuits are just made up of smaller things that you're just trying to apply power to. So in a series, think of you take a battery and you take a wire connected to a light bulb. Take another wire connected to another light bulb. Connect it to another light bulb. And then you've got 3 light bulbs and you're just going in a circle from the positive lead to the negative. Those are in series. What happens is that the draw of power is going to cause all the lights to dim, right? They're not going to be as strong as they can be because they're all drawing against the one bulb, or they're all drawing against the same current. There are things you use current for, series for, and there are things you use parallel for. But at a base level, just understand that they're wired like in a daisy chain. So if those were all switches, like in your kitchen, you had your oven and your refrigerator and a light switch, they'd all have to be on at the same time for power to go out and to the next device, in and out and in and out. Edison is so loud right now, I apologize. Parallel is where you have your battery or your power source and you have your line coming out, and then you have separate lines to feed to different bulbs, right? Let's see if I have a good picture for this. It might be better with a picture. I do. Okay. So this is a parallel circuit, right? So these are all draws. These resistors here. No, those are not resistors. Are they? Doesn't matter. Your power source is the 1 and 8. That's with the positive with the horizontal lines. Like Christmas lights. Christmas lights are serial. Kind of. Because they have them now. Well, I guess they're separate circuits. They've split them up. They distribute. But anyway, the way to look at it is the circuit, the parallel circuit, is kind of feeding each of these loads at different intervals of cycles, right? So it's going to take one path and another path and another path, and everything's going to be lit, and it's going to be lit based off of the power of that one battery. The problem, and so the way to think about this is, if you're thinking about how batteries are used, like if you load them up in a series or if you load them up in parallel, you will get higher outputs depending on how you wire them. Some are better for redundancy, some are better for parallel, some are better for increasing the power if you want to like stack them up to get more power to like a radio or something like that. A lot of people do that. They make battery packs. Okay. All right. So there's a lot of stuff. So this whole page introduces decibels, but there's no question from the question pool in this. So really, I think it's important to understand it, but you don't have to spend an absorbent amount of time there. So let's just cover it overall. You were introduced to the decibel in your studies of technician class. You're right, we were. As you become more and more experienced in ham radio, you'll notice the dB everywhere. It's a standard way of referring to power or voltage ratios. The formula for comparing decibels is dB 10 log metric 10 power ratio is basically 10 log metric 10. So that's your voltage ratio to power ratio. That breaks down, okay, when you break it down, is 10 log and 20 log, and that's right there is your example. That's on page 4.3, where we're at right now if you're following along. But basically, you're just going to go through and you're going to replace the different variables and get to your answers, which is pretty straightforward. Most of this stuff is pretty standard math, but I don't want to assume that you guys know all this stuff. But still, even if you get hit with like the hardest math questions in the different sections, you're still not just going to get bombarded with the math because it's split. It's split in all the different groups within the test, all the different sections. Okay. Okay, this is actually a question, and this is easy to remember. Okay, a very useful value to remember is that anytime you double the power or cut it in half, there's a 3 dB change. Just remember that. Remember that forever. A 2 times increase or decrease in power results in a gain or loss of, and then it's the same log metric equation. You just take your 10 times 0.3, which is the what do you call it? Whatever you double or either go increase by half or decrease by half. Just multiply that by 0.3, and there you go. Or divide by 0.3. Not a lot of questions. See, they spend a lot of time talking about converting, dB change, vice versa, all that stuff. And you do need to do this, but you don't need to do it. Oh, we got somebody that just passed extra a few weeks ago. Wow, good for you. KF5VGK. Congrats. So the big thing to remember from this dB part, and they make a point of it because it's in the test, is remember that when you double power, you cut it in half, there's a 3 dB change. Okay? In either direction that you're going. Okay. See, a lot of this stuff, I don't want to go into a tirade. Brad Martin is making a clarification point. So to not confuse people, power does not equal amps. For example, if you load batteries in parallel, you can draw more amps where batteries in series is more volts. That is correct. Yes. So I believe, going back to the first page, amps is just used to measure. It does not equal. And depending on how you lay out a circuit, it can, as Brad has said, it can change how that is measured and read out and displayed and used in practical sense. What's up, Paul Glover? The kids are so distracting to me. I apologize. AC power. So we talked about alternating power. AC power was covered in the technician, so is DC, but they're covering it again, and they're using, again, kind of a simple to know. As an electrical power become more common, it is important to know how much AC voltage delivered the same power in comparison to DC voltage. The power equation is quite clear. P equals E squared divided by R. That's the equation. I don't know where Leia is, and my poor dad is trying to keep Edison quiet, who is a monster. Literally a monster. But what value for E should be used for AC power? The peak voltage, an average, or what? The answer turns out to be root mean square, RMS. Okay? So if RMS voltage is used in the equation shown above in calculating power, the result is for AC signal is the same as for the unvarying DC voltage. So there's your question. So go back over that again and say, all right, read this again. If RMS voltage is used in the equation shown above for calculating power, the result for the AC signal is the same as for an unvarying DC voltage. Okay? Got to remember that. Root mean square is the method to calculate RMS voltage. It is the root mean square sum of squares of an average mean value of the signal's voltage. If the voltage of more than one waveform are added together, first square the amplitude, then sum them together and complete the average. That's the mean. Okay. So, for example, they used an RMS. The most common AC waveform in all, the RMS value is simply 0.707. RMS value calculated for any waveform, but sine wave. So sine wave constant, right? This won't work for square waves, and I think they said that. Do not use these formulas for waveforms that are not sine waves, such as speech, square, or DC voltage combined with AC voltages. So they're using a pure sine wave, which comes out to 0.707, and that's how they handle the rest of these equations. So they're using the sine wave as a constant, as I put here. And there's your sine wave. We already covered AC, alternating back and forth. That's how we're able to get this changing wave, right? You have to have that for there to be AC. Otherwise, it would be a DC. All right. Here's another one. So, question that's in the pool. A sine wave with a peak voltage of 17 volts has an RMS value of V over RMS is equal to, again, 0.707 times 17. That's your answer, 12. It's a really easy one. Hope you get that one on the test. That's easy to remember. It's always 0.0707. Okay, so this is a practical thing that you're going to need if you want to ever get into amplifiers or anything like that with ham radio. Peak envelope power. A lot of things like amps are measured in PEP, and they're referring to this peak envelope power. So I'll read some of this, and then we'll cover some of the voltage, the PEP. You are sure to agree that the full amateur power limit of 1500 watts certainly that's dumb. That's a dumb joke. PEP is the average power of one complete RF cycle at the peak of the signal's envelope. It's not the power at the peak of an RF cycle during a peak of the signal's envelope. Okay, PEP is used because it's a convenient way to measure or specify the maximum power of amplitude modulated signals. Amplitude modulation, which is AM radio or AM mode. Okay. So bringing back our RMS, right? No, I'm sorry, that's sine wave. 0.707 times where's V? Voltage over P minus P squared over 2, and R is either your resistance or your RF. Example, if PEV is 50 volts across a 50 ohm load, the PEP power is 50 times 0.707, again that's the sine wave constant, over 50 for the ohm load, 25 watts, because it's squared. Okay. These two as well. Some of this stuff is going to be boring, and we just have to slog through it. I apologize. But give me a thumbs up if you're watching this, if you're sticking with me through this whole thing. This is going to be a less popular video because of the because of all the boring nerdy engineer stuff. Which, to be honest, this is just kind of basic. This is like basic level. I will go on my soapbox really quick while I'm doing this. There is a school of thought. I happen to be in this school that you really just need to get the license, and then a lot of this stuff will become self-evident because You will experience it through doing. That's the reality. You're going to get better. You're going to get better at it as you do it. Chase Gleason. I don't even know what the heck that is. That's an interesting ASCII drawing you made for me there. You're going to learn by doing. You're going to get out there. You're going to find things that interest you. You're going to experience things that you don't like, and you don't have any interest in. And you're going to shy away from those things. You're going to focus on the things you do like maybe it's antenna building. And you're going to learn about antennas once you figure out what it is you're interested in antennas. The trick is giving you the exposure to it, giving you the exposure to the thing that you might not have ever heard of or might not have never known about. If nobody ever shows it to you, if you never have an Elmer tell you, hey, we're doing this really fun thing. It's called soda, right? Take Jerry, right? Jerry the Elmer. The what did I call him? I called him the other day. What am I calling him? The soda prophet? No, not the soda prophet. Anyway, the master of soda. You have to be exposed to it or have someone show you it before you learn or find that you want to love doing it or be interested in it. And then once you have that passion for it, that's what leads you to learning more. So I appreciate that there's these barriers to entry for a lot of this stuff, but technician in general should be pretty straightforward, and a lot of people should be able to do it pretty easily. So, all right, 4.3, I think we got a lot of pages to go, chapters. This chapter is very big. We're going to talk about components because those are the things I love the most. I like circuits. Thank you, Tom Garcia. Appreciate that. Okay, so the way they broke this down was they started with the simple components like resistors and they move into other components. There are all kinds of cool stuff to read. This takeaway box is great. All the stuff, basic components, is great. We're going to talk about the figure on the next page. Basically what this comes down to is resistors that can dissipate several watts of power. Okay, that is what a resistor does. It is set to a certain power setting, and then that's what it allows to flow through it. That's all it allows to go through. That's its job. It slows down the flow. Well, slows down the flow or reduces the flow. Somebody in the chat will correct me. I don't need to even... Anyway, you use resistors to slow things down, and you use capacitors to store and hold. Capacitors can be used in other ways too, but let's look at some components. Okay. I like this graph a lot. I think you should laminate this. I think you should make a copy of it and laminate it because it pretty much breaks everything down. And you'll notice that there are there's some trends, right? So this is a resistor, this little wavy guy, right? Then there are adjustable, variable, tapped, thermistors, and then photo. So photoresistor and thermistors are heat resistors, okay? Those are all types of resistors. Hey, what's up? Jerry's listening. Capacitors, right? Capacitors either prevent flow in one direction or they store... let me take that back. It's diodes that do that. Diodes do that. Never mind. Capacitors hold... Well, we'll talk about that more. But basically, a capacitor, in its most general way of usage, is it kind of charges up and then it just kind of acts like an open circuit and regulates the power to the feed. So whatever the feed is that's coming in kind of gets to that point and then just kind of maintains. Maintains. That's why, like, if you turn off a power supply and then it's like, right, it's like slowly burns out. It's not a battery because it doesn't have a chemical substance that the energy is placed into. The electricity, energy, whatever, is placed into. The capacitor is loaded up, and then it kind of slowly discharges. Still quickly, but not as fast as the whole circuit. Robert Adkin, I agree with you. I hope they do expand the technician. Okay, so the things you're going to experience like the most are going to be resistors, capacitors, and diodes when out there actually working on stuff. Diodes, that's where you find LEDs, light emitting diode. Michael the Pyro says not going to happen. Yeah, I totally think it's going to happen. I know people are pissed, but I don't see why. There's lots of different versions of diodes, but pay attention to the arrows. The arrows denote the flow, right? So from positive to negative. And diodes, I'm jumping ahead a little bit, but I just like building kits. So diodes only go one way. And if you put them in wrong, your project won't work. So make sure you follow the schematic as best you can. Otherwise, you'll be an unhappy kit builder. And in fact, that's the first thing you always tell people. It's like, hey, if your project's not working, okay, go check all of your diodes. Just go do it. Okay, then you got inductors, and those are basically coils, right? Coils that you used for things that we'll talk about in the future. And we can skip over this. But I recommend you make a copy of this and then laminate it. And transistors are active. Most of this stuff is passive, right? They work differently depending on what's going on in the circuit. Most of the time, these guys are always doing a specific job. Okay? Let's break them down further. So we're still talking about resistors. A resistor. Oh. See, this is one thing I don't like about this book. Okay, so you got this cool, great. This is great. And they're showing you all these different kinds of resistors. That's a surface mount resistor. It's the size of like a quarter or a dime. Tiny, right? Doing a specific job. And then they're like continuing on a sentence, and then that was part of a question. They couldn't have just moved the page. Look at all this white space. Like, why couldn't they have... Let's go back, which is now over this page. So you get down here and you go, okay, so I'm starting back over from the beginning. Temperature coefficient, or TEMCO, may be either positive or negative depending on the material from which the resistor is made. Oh, okay. Yeah, the bands are horrible right now. Although... Oh, look at that. Listen to the sounds of that. 7,300. So good. So good. Okay. Did we jump over to inductors? No. We're going to cover parasitic induction, and then we're going to talk about inductors. Okay. An inductor in radioelectronic uses, the parasitic inductance of a resistor is important. Means an unwanted characteristic resulted from the component's physical construction. Jesus. Sorry again with the kids. Wire wound power resistors are made by winding resistive wire on ceramic form, making a small coil. This type of construction results in significant amounts of parasitic induction that is generally unimportant at low frequencies or DC. What? Guys! Just get out of it. Go on a walk. Go on a walk. I am losing my mind right now. I can't focus. I apologize. It's just like the worst stream. I may have to do this stream again. Oh, man. If such a resistor is used in a radio frequency circuit, though the induction is often enough to disrupt the circuit's operation or affect the tuning. If such a... let's read this again, because, see, I'm not thinking. If such a resistor is used in a radio frequency circuit, though the inductance is often enough to disrupt the circuit's operation or affecting the tuning. If such a resistor is used in a radio frequency circuit, though the inductance is often enough to disrupt the circuit's operation. Okay. Be sure to use one of the non-inductive resistors. Okay. Great. Wow. Yeah, Zach. Hodge is getting pissed. Yeah, a little bit. Because it's kind of like one of those things. It's like if it could be a dog, or it could be a kid, it could be whatever. If you say, no, honey, and then you don't get the result you wanted, and then you proceed to say no, honey, 18 more times, you're being a crazy person. Go do something else. Switch it up. Change the game. Oh, I didn't even read about inductors, did I? So I don't know if you know this, guys, but... Yeah, it was a horrible sentence. That is a horrible sentence. Okay. So figure 4. See, there's some things that this book is like, it's telling you about it. Okay, it's starting a new section, and then it's saying figure 4-6, which is ahead of the next. It's the next page. Inductors and inductance shows several common types of inductors and their corresponding schematic symbols. Double lines next to an inductor indicates the presence of magnetic core. Important. As opposed to an air core. The variable inductor in the middle also has a magnetic core, showing that double lines as a variable inductor is optional. Okay, so let's break these down. Toroid, right? These are all up in your radios. Variable, meaning it has some kind of tuning control to add coils to it. And then an air core. So, case in point. There's an air core on this device. See that coil? Right? Air core. So an inductor's job is to store magnetic energy, right? So the inductance of an inductor, the measure of its ability to store magnetic energy, is directly proportional to the square of the number of turns and the area enclosed by each turn. Making an inductor longer without changing the number of turns or diameter reduces the inductance, its magnetic capability. The higher the inductance, the greater the amount of magnetic energy is stored for a given amount of current. Increasing the core's ability to store magnetic energy is called permeability. Okay. When you do different... we had somebody crash their computer. Inductors are used in radios, obviously, because everybody talks about winding toroids. But the big takeaway, and it's one of the big questions from the general, is in this example, they're sharing a magnetic field because they're in line with each other. See, this is the magnetic field. So what it's trying to say is when you have power here via switch or whatever, this is just picking up the EMF. It doesn't even have to be on. It's just picking up the EMF. So what you have to do is you got to take this whole guy and you got to rotate him 90 degrees. Then they won't be parallel. They will not be able to share that magnetic field. And that's what the question says. If the coils are wound along a straight axis, the coils may be placed so that their axes are at right angles to each other. Okay? Got to have that. Okay, so we talked about capacitors. Capacitors are two connectors that are placed within a certain space or gap to each other. Connectors, not connectors. They call them plates or foil or just, wow, my brain's totally fried right now. Sorry about that. That took me off my game. I got to be honest. I should drink some more beer. Let me answer a question so that I can recenter myself. Tom Garcia asks, is a magnetic loop antenna just a big inductor? So, if you're talking about the hoop, no. The hoop, people make the hoop out of coax. The driven part is the smaller hoop, right? So, I don't believe that it's considered an inductor per se. Okay, so a capacitor is two reactive somethings separated by either air or some kind of dielectric. It could be cardboard, it could be dielectric paste, lots of things, right? As said here. So this is an electrolytic capacitor. These are variable capacitors, which you end up using these a lot with radios too. Anyway, All capacitors have the same basic structure, two conducting surfaces. See, that's the way to say it. Two conducting surfaces. Should have just said that. Separated by a dielectric that stores electrical energy while preventing DC current flow between the surfaces. That's their job. The larger the surfaces, the closer the separation, and the more electrical energy the dielectric can store, the larger resulting capacitance. So capacitors can be gnarly. That's why, like, if you've ever opened up a CRT monitor, you try and ground it or hit the caps with something that's grounded, or you're holding a grounded piece and you're trying to get the stored energy and release it, because there's all kinds of stuff that'll end up whacking you if you're not careful, particularly in old arcade machines. Old arcade machines are bad at that. If you guys have ever rebuilt arcade cabinets. Now would be a good time to talk about the beer, since everything else is going to hell in a handbasket. This beer has maintained pretty good notes. A little sweet, though. I don't know where the sweetness is coming from. Yeah. So Sabathius says, I think that's right, Sabathius. So there is it has a variable inductor in it. That's what so if you've ever seen it before, it looks like a bunch of vertical circle metal discs, and then the rotator on the side turns them in kind of together in time. That is an inductor, but your hoop is not a big inductor. So sorry if I was reading too much in what you were saying there. It was Tom that was saying it. Chase, where should we get the beer? You can get the beer at Bevmo or Total Wine and More. Neil Smith. Horny Devil. It's good. It's real good. Cool. I should just have Jerry hop on right now. We should just talk about soda. I'm thinking about doing a Mount Baldy activation, where I'm just going to go up there and I'm going to camp like he did. By the way, that's a good video. You should go watch his video on that. Yeah, more fun than this right now. Guys, stop yelling. I think I'm going to have to end it. What time is it? We're almost an hour. Let's just go back and look at the 7300. Why don't we just do that and we'll pick up where we left off next week. I did want to get further, though. So here, let me at least get through some of this stuff. There are some questions that are important. This one, ceramic capacitors are the little disc type capacitors. You use these in a lot of projects. The reason why some ceramic capacitors are used is because they're low cost. They're cheap. They're just little itty bitty things. You can break them. You can get a ton more. The electrolytic and large surface area of the large capacitors create large capacitance and comparatively small volumes. Electrolytic capacitors can be seen near the center. This big ass guy. That's a question. What is the question about exactly? Let me go back. Aluminum electrolytic capacitors use metal foil for the conducting surface, and dielectric is an insulating layer on the foil created by a wet paste or gel of chemicals. Tantalum capacitors are similar to that of porous mass of tantalum is immersed in electrolyte. The electrolyte and the large surface area of these capacitors create large capacitances in comparatively small volumes. Okay. And they're more expensive. So there you go. Let's leave it at that. Oh, no, let's do one more and then we'll end it. I think you already did, Jerry did Mount Baldy though, so I always feel, yeah, sorry, Alan. Here's the important thing. Look at the polarity markings on the capacitor to install it correctly. Okay, there you go. That is where we're gonna stop doing the book thing for now, because I can't think with the kids yelling in the background. I did not expect this to be so bad. They're really excited because my dad's in town, and my dad has a really good time playing with them, and they really like to play with my dad. So they're constantly trying to get him to, get off the couch, come play with us, all this craziness. So I get it. I can't be mad, but at the same time, maybe not sit right in front of my door and just scream. Thank you for the $1, bro. Thank you. For my sanity. $1 for my sanity. Thank you. I appreciate that. What the hell? We're pretty much at the end of this. Let me, we got 5-10 minutes. Let me do this really quick. Gotta say thank you to the patrons. Maybe not for this episode of the Crash Course, but thank you, Carrie, Michael Nieswender, Terry Hines, Jason Brown, Jason Siebert, Franklin Lewis, Henry Bond, Danny Miller, Vaughn Dobbs, Chris Ebert, and the Brew Crew. Now, again, that's a special level of Patreon. Those are they get different stuff than the rest of the patrons. If you'd like my newsletter, which I produce every month, it's basically $1. Costs you $1. And I send that out in the beginning of every month. Last month we talked about my failed soda activation and the details of that. And then I believe we talked about my first article was talking about my thoughts on how people... Oh, thank you, Tom Garcia. Thank you so much. I appreciate that. $1 for my sanity. Thank you. It's like the guy holding the hat. Like, can I have $1 for my sanity? You know what? I got electrolytic grease right here. They're talking about a baby machine? I don't even know what's happening in my house right now. No, I won't mix my barbiturates. Now I'd lost total track of... Oh, yeah, the newsletter. So a lot of people came to radio from CB. And there are other ways that people came to radio, but CB was one of the big ones. And now I think we're going through a kind of a... not a fad, but a phase where we're getting more people in that are preppers. And you're getting the Chinese radio influence and all that stuff. So I kind of broke that whole thing down last month, or this month's release. So that's still available if you'd like to get on that whole thing. Let's see. Yeah, DJ Schnibs is the man. Yeah, Jerry. Got something tomorrow. If I can gently make that. Jerry's the man. Okay, you know what? Let's go back to the dulcet tones of the 7300. Hold on, let me switch over to something so that you don't have to see this camera going crazy. And 80 meters is popping right now, so we can... Okay. Beauty. All right. this chat, man. I apologize to everybody that's watching this chat, but maybe that was fun. I don't know. Maybe you enjoy a little craziness. I want to take... God, I'm doing this at the end of the video. This is like the worst time. I need to really say how thankful I've been to MFJ. MFJ has been like really cool to me recently. Case in point, this MFJ 4230 DMP, my power supply that I'm using right now. It's a nice little portable 30 amp switching power supply. It has power pole connectors in the back of it, so you don't have to use anything non-standard than what you normally use. So I'm oh, thank you, Ginger Ninja. Upgraded to general and my girlfriend got her ticket last week. Love your stuff. Thank you. KF7 IGN. Do you work for IGN? Are you like IGN's the gaming magazine, right? And gaming website? Yeah, so the MFJ 4230 DMP is a really cool power supply. I'm powering both of my ICOM radios here off of that power supply, and it works really well. I used it with the Zygu. I've used it with a ton of different stuff. It's a very nice power supply and really small platform. It doesn't get too hot. It doesn't do anything. With that said, I made some plans for like a little wooden thing that I can set on top of my desk to be kind of a better arrangement for the radios. I'm gonna take this kids out back and we're gonna head. You tell me what I'm gonna do. I'll tell you what I'm gonna do. These kids are driving me crazy. So I think these guys have been rag chewing for this entire time. I got to come up with an auto tuner though. I think that was what the takeaway from my learning radio. Yeah, it's a switching power supply.
KJ6A10 at the Commons. K6 middle green light.
In the garage, I have such functionality. And then I would keep a CW transmitter with the front door open. The screen light out and plug waiting with my CW.
So, 80's poor right now. Oh, Daniel, I'm so sorry. Oh, Daniel, you finally made it to a live stream and you came on the worst one I've ever made in my entire life. I apologize. I apologize deeply. I have but it makes quite a bit in RFI. I don't think so. Right now. It's just sitting here because I'm just doing a demonstration of it. But it's not going to live like that. I'm going to separate it. How did you deal with it? How did you deal with the RFI if you have RFI? 80's porn. Oh, the band is... Yeah, Tom Garcia, you got it. And that's one of the reasons I got it. Was it's great for field day. It's a field ready radio. There's plenty of, like you said, plenty of batteries that will work this thing completely. With that said, oh man, the video that I'm gonna put up when I went to Ham Radio Outlet. What's the new one? 7610? The 7610? It's like the big brother to the 7300. It's like $3,400. The screen on that thing is intense. It is really crisp. It is like really, really crisp. Like very tight lines. Amazing. I was like, there was a moment there where I thought, should I just go out and buy this one? It was too big though. I like the size and the form factor of the 7300. I really do like the size. I think the size is perfect for me. I don't have a lot of craziness that I want to do. I'm not a contester. I like the soda stuff, to be honest. I'm satisfied with that. And the ability to maybe chase some people that are local is kind of what I'm looking for. And just to occasionally talk to my friends and stuff. I'll be able to hit Jerry. Where's Jerry at? This guy's... Wow, he's 20 over. Oh, he was... This is... Lid Town. Yeah, dude, that 7610 was insane. I'm going to make a note right now. My note is buy some of those egg crate material and then line this whole wall with it. So I'm gonna make a note of that right now. Buy egg crate sound deadener. So thank you to the patrons. You just bought some sound deadening for the ham shack here, so that we can quiet down the the intentional interference. So I just got this thing a couple hours ago, so I don't know all the little ins and outs. there is something you can do to change the waterfall, because this waterfall's not great. It's all the same color. I really need some contrast in there. I need like a yellow for where there's an active station. I do need to track this down. There's a blip that I keep getting. I think it's Ethernet. No, that's a big signal. Charlotte! Hey, shut up. All right. I'm done. I'm going over to Discord. Bring your questions. We didn't do a proper Q&A on this one. This is rough, guys. It's only going to get better from here. All right. So, again, I appreciate it. I appreciate you sticking with me through this whole thing. We'll do better next week because the kids won't be here. Love you guys. I love the support. Thank you so much. If you haven't already, please join the Ham Radio Crash Course on Facebook. Please hop over to the Discord right now. I'm jumping over there right now, and I'm going to polish off this beer. So, take your questions over to best stream. No. Take your questions over to Discord, and let's have a talk about Ham Radio. Okay, guys. We'll see ya. I'm going to beat some children. No, I'm just kidding. I won't do that. I love them.